Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Math 7, Module 5, Lesson 1, Chance Experiments. Classwork. Have you ever heard a weather forecaster say there's a 40% chance of rain tomorrow, or a football referee tell a team there's a 50-50 chance of getting a heads on a coin toss and to determine which team starts the game? These are probability statements. In this lesson, you're going to investigate probability and how likely it is that some events will occur. Okay, so it says here, example 1, spinner game. It says suppose you and your friend are about to play a game using the spinner shown here. Rule the game. Decide who will go first. And 2 says each person picks a color. Both players cannot pick the same color. So I'm just going to make this up, so I'm going to say player 1 and player 2. Okay, so play the game. Remember to record the color the spinner stops for each spin. Okay, now the problem here is blue has a 25% chance of occurring, red has a 25% chance of occurring, but green has a 50% chance of occurring. Okay, so since this was to be done in class, I needed to figure out how to animate this. So what I did was I found a website, and there is a spinner that you can click on and that I'm going to use. But the only problem is I have blue, red, and green is 50%, blue's 25%, and red is 25%, totaling 100% of this circle. So each person picks a color. Both players cannot pick the same color. So let's say player 1 chose green. So player 1's in green. Instead of writing the word green, I'll write player 1 in that color. So here's player 1, and player 2 chose red, so we'll just leave that red. Okay. Each person takes a turn spinning the spinner and recording what color the spinner stops on. The winner is the person whose color is the first to happen 10 times. So now we're going to tally up results, spinning the spinner. So I've got this website here. Now blue is yellow and green and red. Okay, so what I've done is I've changed this. I couldn't figure out, or they didn't allow me to change the colors of the spinner, but if you can see here, this is green, green, and I hit it so it spun. So as you can see, I have green here, 50%, blue here, 25, and red here, 25. So we're just going to look at the result, ignore the colors when it's spinning, and there's my first spin, green. Okay, so I'm going to do a few spins at a time so I don't have to keep going back and forth. So spin 1, green. Then blue. Then red. I'm going to write those down. So player 1 got green, then blue, then red. Red again. Green. Blue. So red, green, blue. Now it says each person takes a turn spinning and writing it down. The winner is the person whose color is the first to happen 10 times. I'm waiting for green to happen 10 times. There's green 1, there's green 2. We've got to keep going. Okay. Okay, green. Green. Blue. So green for the third time, green fourth time, and blue. Green, blue, green. So green the fifth time, blue Green the 6th time. Green. Red. Green. So green a 7th time, then a red, then a green the 8th time. Okay, we're not at 10 yet. We need 2 more greens. Green. Red. Blue. So green a 9th time, red, blue. So I need 1 more green to get to my 10th green. Red. Green. There it is. It's red and then green on my 10th spin. So I spun the wheel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 times. Okay, so the number of times I spun the wheel equaled 20 before I got a green 10 times. Now player 2 is going to do the same thing. Let me move this up here. So player 2 is now going to spin until they get their color, which is red, 10 times. So we have blue, green, red. So I'm going to write that. Blue, then green, then there's my first red. Green, green, blue. So then it went green, green, blue. Green, red, blue. So green, red twice, blue. So that's 9 times. Red, red, blue. So red a 3rd time, red, actually that was 10 there, so I'll write it on the next line. Red a 4th time, and then blue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spins. We're on now on 12th, now we're on 13th spin. Green, green, green. So that was green, then green again, then green again. Red, blue, blue. So it was red the 5th time, blue, blue. Now we're at 18. We only have 2 more spins. Red, and green. So red a sixth time, and green. So it says each person takes a turn spinning the spinner and recording what color the spinner stops on. The winner is the person whose color is the first to happen 10 times. So after 20 spins, player 1 had 10 greens and player 2 had 6 red after 20 spins. So n equals 20 here. We had 6 successful results. And in this case, we had 10 successful results in the same number of spins. I forgot my 0, 20, n equals 20. So player 1 wins. Okay. Number 1, which color was the first to occur 10 times? So going back, I just did this 10 times for one person, then 10 times for the other, but let's assume it was alternating. Okay. So then the question says, which color was the first to occur 10 times? And the answer is green. Do you think it makes a difference who goes first to pick a color? And the answer is definitely yes. Because if I were looking at this spinner and I saw that big, huge area of green and then the smaller red and blues, I would want to pick green because it looks like it's more likely to occur. So if I went first, I would choose green. Which color would you pick to give your best chance of winning the game? Green. Why would you pick that color? 50% chance of winning. Chance of getting green, where red and blue each had only a 25% chance. Number 4 says, below are 3 different spinners. On which spinner is the green likely to win, unlikely to win, and equally likely to win? Okay, so equally likely would be 50-50. That would be here. On which the green is likely to win would be a larger area of green, which would be here. And unlikely to win if green were smaller than the other, which is here. Okay? Example 2. What is probability? Probability is a measure of how likely it is that an event will happen. A probability is indicated by a number between 0 and 1. Some events are certain to happen, while others are impossible. In most cases, the probability of an event happening is somewhere between certain and impossible. For example, consider a bag that contains only red cubes. If you were to select one cube from the bag, you are certain to pick a red one. We say that an event is certain to happen, has a probability of 1. If we were to reach into the same bag of cubes, it's impossible to select a yellow cube if they're all red, and an impossible event has a probability of 0. That's, if you think about it, it's percent, and 1 is equal to 100%. So whenever we change a percent to a decimal, we move the decimal 2 places to the left, and that'd be 1.00 or 1. So description. Some events are impossible. These events have a probability of 0. Example, you have a bag of 2 green cubes and you select one at random. Selecting a blue cube is an impossible event if they're all green. There is no way to select blue cubes if there are no blue cubes in the bag. Okay, I'm not going to continue reading this, okay? I'll leave this to you on your own, but it just explains the likeliness of things occurring. Okay, so moving on, the figure below shows the probability scale. So here's a probability scale where impossible is 0, certainly going to happen is 1, likely is above a half, equally likely to occur or not occur is at 1/2, and anything between 0 and 1/2 is less likely or unlikely to occur. So if anyone ever goes into a casino, 99% of the games you play are here. The house usually always wins. There is a slight advantage. Here's where blackjack would be. Just a little over 50%. If you play the same dollar amount over and over and over and over again, it's just slightly above 50% for blackjack. Slot machines, I think, are down around 4%. Okay, so moral of the story, don't gamble unless you own the casino. Build casinos, don't play at them. Exercise 5 through 10. Decide where each event would be located on the scale above. Okay, so we need the scale, so I better bring that back and let me get rid of my little display here. All right. Place a letter for each event in the appropriate place on the probability scale. Event A. You will see a live dinosaur on the way home from school today. Yeah, I'm going to put that at impossible. Okay. B. A solid rock dropped in the water will sink. I would say that would definitely happen. A solid rock dropping in the water will sink. C. A round disc with one side red and the other side yellow will land yellow side up when flipped. Okay, well that's like a coin, and that would be equally likely to occur. D. A spinner with 4 equal parts numbered 1 through 4 will land on 4 on the next spin. Okay, well if they're equally likely, you have a spinner split into quarters, 1, 2, 3, 4. The likelihood of it landing here is less than half, which would be about halfway or a quarter, and that would be here. All right, E. Your full name will be drawn when a full name is selected randomly from a bag containing the full names of all the students in your class. Well, if there are 30 students in your class, 1 out of 30 is way down here, and that is E. F. A red cube will be drawn when a cube is selected from a bag that has 5 blue cubes and 5 red cubes. Let me go back to E though. E can move. So the smaller the class, the more likely it is. If it was a class of 2 students, I would have it here. The likelihood of me being chosen over a second student is here. If there's 3 students, it'd be 1/3 or about here. If there were 4 students, the probability would be a quarter, it'd be here. And if there are 5 students, 6, 7, 8, 9, 10, all the way up, then the more students there are, the closer we're getting to impossible. Okay? It's never impossible if your name is in the bag, though. So it would be anywhere between 1/2 and very close to 0. All right, let's go now continue on to F. A red cube will be drawn when a cube is selected from a bag that has 5 blue cubes and 5 red. Well, 5 blue, 5 reds, equally likely to occur, so I would put F right at the 50%, equally likely. That looks like an E. Let me do that again. Okay. G. Tomorrow the temperature outside will be negative 250 degrees. I hope not. G. That will not happen. Hey Siri, what's the coldest spot on Earth?
I found something on the web about what's the coldest spot on Earth. Check it out.
Okay, it's Siberia, Antarctica. Hey Siri, what's the temperature in Siberia?
It's currently 68 degrees in Siberia, Indiana.
Wrong Siberia. Hey Siri, what's the temperature in Siberia, Arctic?
It's 68 degrees right now in Siberia, Indiana.
Okay, she's stuck in Indiana. And that's a song, but I'll stop there. Number 6. Okay, so anyway, not likely to occur. G. 6. Design a spinner so that the probability of spinning a green is 1. Remember, that's 100%. Okay, so here's my spinner. The probability of drawing, well, let's do it in green since it's supposed to be green. Okay, so let's create a spinner. Let me use my fancy shape recognizing pen. Wow. Okay, and then I want it to be shaded green. Okay, so, and then I need a spinner. Okay, so there's my spinner. Design a spinner that probably spinning a green is 1. I don't care if there's lines in between here or not. You spin that thing, you're going to be landing on green. Alrighty then. Number 7, design a spinner so the probability of spinning a green is 0. Okay, here's a spinner, so the probability of spinning a green is 0. Now it says design a spinner with two outcomes in which it is equally likely to land on red and green parts. Okay, so here we go. Here's a spinner with two outcomes with equally likely to land on red or green. All right. An event that is impossible has a probability of 0 and will never occur, no matter how many observations you make. This means that in a long sequence of observations, it will occur 0% of the time. An event that is certain to has a probability of 1 and will always occur. This means that in a long sequence of observations, it will occur 100% of the time. Number 9 says, what do you think it means for an event to have a probability of 1/2? Okay. So I'm going to type this because it's hard to write. So let me start a text box with a normal text size. What do you think it means for an event to have a probability of 1/2? Okay. So an event is equally likely to occur. What do you think it means for an event to have a probability of 1/2? An event is equally likely to occur. Okay. For example, if you spin the spinner in number 8, red will occur 1/2 of the time. Okay? What do you think it means for an event to have a probability of 1/4? Okay, the answer is going to be very similar, so I'm going to copy this down. An event is... That's gone. No, that's not going to work. Okay, I'm going to try to use their wording here. This means that let's say, in a long sequence of observations, an event will occur 25% of the time. Or 1 out of every 4 trials. There, that sounds pretty good, I think. Okay, that is the end of lesson 1. Review the lesson summary and go do your problem set.